Within this equation, x and y are different variables. As x changes, y is changing. And that's why we do a table of values. This is basically saying for certain values of x, what do we get for y? It's often easiest to start with 0 and 1. Now I have filled these in for us already, but let's just see how I got those values. So if x is equal to 0, then y must be equal to 0 squared minus 0 minus 2. 0 squared is 0, minus 0 is still 0, and then minus 2. We get that? And we can do the same for 1. We'd see that it's minus 2 as well. So what we need to do here is we need to substitute in minus 2, then minus 1, then 2. So if we put minus 2 into here, now, to be honest, I would just put this straight into a calculator. I wouldn't risk doing this in my head. And you've got a mode called table mode. So if you've got a Casio calculator, you can press mode. And then you press 3, that puts you into table mode. And then it's a function of x. F of x is equal to something. So we want to put f of x is equal to x squared minus x minus 2. Now, when you're trying to put x into a calculator, you can press alpha, that's the red button near the top left, and then press x, which is the closing bracket, and that's then where you should see x in red. And then it's going to ask you, where do you want to start? Now, we're starting at minus 2, so you press minus 2, then press equals. Then it asks you, where do you want to end? We want to end at 3. So we press 3, then equals. Then that's step. We go in ones here. So we have a step of 1. And then it should give us a list of values. So you could do it that way and then write in what these are. But if you're doing it a more traditional way and maybe you don't have this function on your calculator, and if you don't, I'd recommend getting a Casio calculator. It's what schools use, it's what tutors use, etc. So we'd put in minus 2 squared. Now you have to be very careful with calculators that when you're doing a negative squared, but you put the negative in brackets as well. Otherwise, the calculator is reading it as minus 2 squared, which is 2 squared is 4. Make that negative, you get minus 4. But in fact, squaring a negative, that's a double negative, and that becomes positive. So we have to be careful that we put that in fully. And then minus, again, I'd probably put this in brackets, but you don't have to. And then minus 2 from that. And we can put that into a calculator and see what we get. We get 4. Now this is good news because we expect quadratics to be symmetrical. You can see that the 2, minus 2 and a minus 2, that's kind of mirrored. The 4 and the 4, that's also mirrored along this line here. So it's going to be symmetrical. Now we can do this over minus 1. Just to speed things up, I would just use table mode here. And in the table mode, we get all these values. We get 4, we get 0, minus 2, 0, and then 4. So I'm just scrolling through the results. You have x on the left, and then you have f of x on the right. F of x is basically your y value. So this is good news as well, because this is symmetrical here. Just to get out of table mode, we don't want to be stuck in there. You press mode again, and then press 1. That gets you back to normal calculation mode. It's very important. You don't want to get stuck into table mode. So for part B, we want to draw this on the graph. The x value of minus 2, and that gives us 4. So we can draw that on here. Minus 1 is 0. 0 is minus 2. And we just plot through all of those. So we get a mark for putting the points on, but we also need to join it up with a curve. And the curve, we need to be careful that it goes through all the points if we can. Then we want to maintain that symmetrical nature, so it's the same on both sides. Now for part C, writing down the coordinates of the turning point. Now a turning point is the point which it turns around. You can see that it's going downwards at this section here. And then it continues to go downwards until it gets to this point here where it turns around and starts to go up. So this point here must be the turning point. Now if we look at our graph, we wouldn't quite get that point. We would get this point here, which they might accept. That's okay. But we probably want to be a bit more accurate and say that it's halfway between both of these. The graph's symmetrical, so it must be halfway between 0 and 1. Halfway between 0 and 1, that's a half, or 0.5. The x-coordinate must be 0.5.